Okay, here's another problem from the linear approximation section. In this one, they're asking us to approximate the change in volume of a right circular cylinder of fixed radius 20 centimeters when its height decreases from 11 centimeters to 10.9 centimeters. And our volume of a cylinder formula is pi r squared h using a linear approximation. Okay, so what I do is I take the formula that they give me in terms of the height. Volume is equal to pi r squared h. And so now in this formula, we know that the radius is constant. The radius is just 20. So I can simplify this formula that they gave us. And I can say, well, therefore, the volume with respect to h is just going to be pi times 20 squared times h. It's just going to be a linear function. It's going to be 400 pi times whatever the h value is. Okay, now we need to find out information about how the volume is changing, so that's going to involve a derivative. So I'll go ahead and take the derivative of this volume formula with respect to h. I can say, well, dv dh, the change in the volume with respect to h, is just going to be 400 pi, because keep in mind, h is raised to the first power, so if you're taking the derivative with respect to h, that 1 comes down in front, multiplies that, and then you have h to the 0 power, cancels it out. Okay, now, this is what's new in this section. I'm trying to find the differential, how much the volume is changing, and I want to estimate it. Well, dV dH, it looks like a fraction, and it can be treated as a fraction. I can say the instantaneous rate of change with respect of V with respect to H is equal to the instantaneous rate of change of V is equal to 400 pi times the instantaneous rate of change of H. Now, this is still an exact equation in this format. However, once I start giving dV and dH some quantity, they're no longer dV and dH, they're delta V and delta H. So some arbitrary change in H gives some arbitrary change in the volume. So in this format, it's an equation, but it's only an equation if these values are infinitesimally small. Well, now that they're not infinitesimally small and I give them some measurement, it just becomes an approximation. So I can say, well, then the change in the volume is approximately equal to 400 pi times the change in H. Now, in this problem, it told us that H went from 11 centimeters to 10.9 centimeters. So I know I could plug in the value negative 0.1 for H. I just plug that into my derivative formula, and I can say, well, then the change in the volume is approximately equal to 400 pi times the change in the height, which was negative 0.1. I'll get that the approximate change in the volume is negative 40 pi, and this would be in cubic centimeters, which of course our problem has here. And then if I check that with what MyLab was wanting here, you'll see that, yeah, that is what they wanted. All right, hopefully that helps out with this problem.